Hello students. So today I am doing class for class 12 science. The topic is continuity of a function. So in the last online class we did theoretical portion on continuity of a function, that is what is meant by continuity of a function and discontinuity of a function. What do you mean by continuity and discontinuity of a function f of x? Okay. So today we'll do problems on continuity of a function. That is exercise 2a from the book Higher Mathematics for class 12 by Sailendra. And this is from exercise 2a. Each question carries 2 marks. So let us do this question number 4. You have to show that the function f of x is equal to x minus within mod there is x is continuous at x is equal to 0. You have to prove that this given function of x whose value is given as 2x minus within mod x is continuous at x is equal to 0. So now in this case, let us first simplify the given function f of x is equal to 2x minus within mod x. Okay. So here given is f of x is equal to 2x minus within mod x. Now first of all you have to check that within mod x, within mod there is x. When is this value of x is equal to 0? When you put x is equal to 0, isn't it? When you put x is equal to 0, then the value within mod sign will be 0. You have to check within mod sign the expression is given as x. When is this value is equal to 0? When you put x is equal to 0, isn't it? Is that clear now? So putting x is equal to 0, what do we get? If you put x is equal to 0, therefore f of x is equal to 2 into 0 minus within mod 0. Which is 2 zeros are 0, within mod means 0, which is equal to 0 minus 0 is always 0. That means if you put x is equal to 0, then f of x will be equal to 0. Okay. Now you have to check or you have to simplify the value for f of x when x greater than 0. When you put x as positive, if x is greater than 0, so how can you simplify this f of x? Okay. जब तिमीले x greater than 0 हाल्छौ त्यतिबेला यो f of x को भ्यालु कति हुन्छ त्यो चेक गर्नु पर्यो. So if x greater than 0 comma then f of x is equal to 2x remains as it is minus also remains as it is. Okay. If you write only x, if x is greater than 0, then x is already positive, isn't it? If x is greater than 0, then if you write only x, x is already positive. Is that clear now? So you can write here x. Is that clear? So forget about this 2x minus for the time being. Forget about 2x minus. Okay. So if you write only x, if x is greater than 0, then x is already what? It is positive. So you can write x out there because within mod x you know that it should be always positive. Okay. So it is 2x because minus sign is out there. You have to write down minus. So if you write only x, x is already positive. So which is equal to 2x minus x is x always. Is that clear to all of you? So if x is greater than 0, then what is the value for f of x? It is x, right? Now if x is less than 0, then f of x is equal to, you have to write 2x minus. You have to write 2x minus because in the question it is given 2x minus. You have to write down this expression, that is 2x minus. Right? And within bracket, if you write only x, if x is less than 0, then x is already negative, but you have to make it positive. So how can you make this x positive? You have to write down minus out here. Is that clear? So if x is negative, but because of this minus sign, it becomes positive. Is that clear? So it will be 2x minus within bracket minus x. So which is equal to 2x plus x, which is equal to 3x. Okay. Now if x is less than 0, then what is the simplified value of f of x, it is 3x. If x is less than 0. So if x is less than 0, then what is the value for f of x? F of x is equal to 3x. Now we can redefine this function. Now how can you redefine this function now? Therefore, you can write here f of x. That is f of x exactly equal to 0. What is the condition? F of x will be exactly equal to 0 when x is equal to 0. If x is equal to 0. Is that clear? कति बेला यो f of x is equal to 0 भयो त? If you put x is equal to 0. So if we put x is equal to 0, then f of x is equal to 0. So write down this one here. That is f of x is equal to 0 if x exactly equal to 0. But if x is greater than 0, then what is the value for f of x? F of x is equal to x. Is equal to x if x is greater than 0. If x is positive, then f of x is equal to x. Is that clear? Next, if x is less than 0, then what is the value for f of x in this case? It is 3x. So you can write here is equal to 3x if x is less than 0. Understood? F of x is equal to 3x if x is less than 0. So we have redefined this given function as f of x is equal to 0 if x is equal to 0. This f of x is equal to x if x is greater than 0. This f of x is equal to 3x if x is less than 0. Now you can check the continuity of the given function now, because this is the simplified function of x. So now you can check whether the function f of x is continuous or discontinuous at the given value x is equal to 0. So in order to check the continuity of the function f of x, you have to find out the right hand limit at the given point, left hand limit at the given point, and the value of the function at that given point. If all these three are equal, then only it is continuous, otherwise it is discontinuous. Is that clear? So now let us do this problem now. So let us write for right hand limit. For right hand limit, what is the way of representing the right hand limit? So limit x tends to, what is the given point here? You have to check the continuity of this function at x is equal to 0. So how will you write down the right hand limit at x is equal to 0? Limit x tends to 0 plus f of x is equal to, this is limit x tends to 0. यहाँ अलिकति माथिबाट तिमीले के लाउँछौ, प्लस साइन लाउँछौ, f of x. X tends to 0 plus means x is approaching towards 0 from which side? From the right hand side. Okay? And on the right hand side, all the values of x, on the right hand side of x is equal to 0, all the values of x are greater than 0. So limit x tends to 0 plus. So what is the value for f of x when x greater than 0? X is tending towards 0 from the right hand side, and on the right hand side of x is equal to 0, all the values of x are greater than 0. So in this case, this represents x greater than 0. What is the value for f of x when x greater than 0? When x greater than 0, what is the value for f of x? It is x. So you can write here x, which is equal to 0 plus means actually it is 0. It is approaching towards 0. So its limiting value will be 0. So instead of x, what can you write? You can write 0 only. So x tends to 0 plus, it only indicates that x is approaching towards 0 from which side? From the right hand side, and on the right of x is equal to 0, all the values of x are greater than 0. Okay? So if x is greater than 0, what is the value for f of x? It is x. So you should write here x. Now we can put x is equal to 0 in this case. So this is x, 0 is the limiting value of x. So you can write x is equal to 0 in this case. So this is your right hand limit. Is that understood? Now similarly you can find out the left hand limit. So how will you write down the left hand limit? For left hand limit, how will you write it? Limit x tends to 0 minus f of x. What is meant by it? X is approaching towards 0 from the left hand side only, and all the values of x on the left of x is equal to 0 are less than 0. Okay, so if x is less than 0, what is the value for f of x? It is 3x. Okay, so limit x tends to 0 minus, this is your 3x, because it is defined as f of x is equal to 3x if x less than 0. So if x is less than 0, what is the value for f of x? It is 3x. Okay, so now you can put x is equal to 0. X tends to 0 minus, it only indicates that x is approaching towards 0 from which side? Left hand side. Okay, and you can put x is equal to 0. That is the limiting value of x. That is 3 within bracket 0, which is equal to 3 zeros are 0. So I think you have understood it. Now you have to get the value of f of x when x exactly equal to 0. So when x is equal to 0, what is the value for f of x? It is 0. So you should write here now at x is equal to 0. Therefore, what is the value for f of x, which is equal to 0? Now put x is equal to 0 in this case. So f of 0 is equal to 0. Is that clear? Now all these three are equal, isn't it? That is right hand limit is equal to left hand limit is equal to the value of the function at x is equal to 0. That is f of 0 is equal to 0. All these three values are equal. So what can you write here? The given function f of x is continuous at x is equal to 0. So we can write here, since limit x tends to 0 plus f of x, that is your right hand limit, and for left hand limit we have limit x tends to 0 minus f of x is equal to f of 0. So all these three are equal. So what can you write? Hence, what can you write here? Hence the given function f of x, hence the given function f of x is continuous at x is equal to 0. Proved. So I think you have understood it. So you can copy it. We'll do the next question now. So now we are doing the next question, that is question number 5. You have to examine the continuity of the following function at x is equal to 0. So at x is equal to 0, you have to examine the continuity of the following function. This function may be continuous and discontinuous at x is equal to 0. You have to check it. You have to check whether this given function is continuous or discontinuous at x is equal to 0. So what is the given function out here? Instead of f of x, usually we write function of x as f of x. But you may write the function as phi of x also. G of x, you may write z of x, h of x, phi of x, etc. These are all the functions of x. Okay. Now in this question, the function is given as phi of x, which is equal to within mod x divided by x when x not equal to 0. So what is meant by x not equal to 0? Either it may be x greater than 0 or it may be x less than 0, but x exactly not equal to 0. Okay, and what is the second function? Phi of x is equal to 0 when x is equal to 0. But when x is equal to 0, what is the value for phi of x? That is your 0. Okay. So let us simplify the first function when x not equal to 0. That means you have to simplify the function phi of x is equal to within mod x divided by x when x not equal to 0. Okay. So let us simplify it now. Now phi of x is equal to within mod x divided by x when x not equal to 0 means when either x greater than 0 or x less than 0. But in this case, x not equal to 0. The x not equal to 0 भनेको के रहेछ कि त x greater than 0 हुन्छ कि त x less than 0 हुन्छ. So let us simplify it. Let us simplify the function phi of x when x greater than 0. Okay. Now when x greater than 0, then phi of x is equal to. So here we assume that x is greater than 0. X greater than 0 means x is already positive. So phi of x is equal to, if you write x is already positive, within mod x means all the values of x, all the value here is positive. Within mod x means all the values of x here is positive. So if you write when x greater than 0, then phi of x is equal to x because x is already positive. Divided by this, denominator remains same, x by x, which is equal to what? 1. You can cancel it, isn't it? x1 is x, x1 is x, which is equal to 1. So whenever you have x greater than 0, then phi of x is equal to 1. Okay. Now when x less than 0, then what is the value for phi of x? Now let us consider the numerator here. It is given within mod x. If you write only x, what happens? If x is negative, then if you write only x, x will be negative, isn't it? To make it positive, you have to write minus out here. If you write minus out here, whatever may be the negative values of x, because of this minus sign, it will become plus. That is, positive values of x will be there. So divided by this x remains same, which is equal to minus 1. So whenever you have x less than 0, then what is the value for phi of x? Which is equal to minus 1. Is that clear to all of you? So now let us redefine this function. So now this question now becomes phi of x is equal to 1. Phi of x is equal to 1. Kati bela ayo? If x greater than 0, right? If x greater than 0. Is that clear? So when x less than 0, what is the value for phi of x? Minus 1 is equal to minus 1 if x less than 0, right? Again, but in the question it is given that when x is equal to 0, phi of x is equal to 0. That means you can write here 0 if x is equal to 0. Okay. Now we have redefined the given function as this one. So यो जुन चाहिँ तिमीलाई क्वेशनमा फंक्सन दिएको थियो त्यो फंक्सनलाई नै हामीले सिम्प्लिफाई गरेर यो फंक्सन निकाल्यौं. अब यहाँबाट हामीले you can check the continuity of this given function phi of x. So for this you have to find out the right hand limit, left hand limit and the value of the function at the given point x is equal to 0. Okay. So for right hand limit, what can you write for right hand limit? Limit x tends to, at what point are you checking the continuity of the function? At x is equal to 0. So right hand limit will be at x is equal to 0, right hand limit will be limit x tends to 0 plus phi of x. Phi of x is equal to limit x tends to 0 plus. What is meant by x tends to 0 plus? What is meant by x tends to 0 plus? X is approaching towards 0 from which side? From the right hand side. And on the right of x is equal to 0, all the values of x is greater than 0. That means it indicates x greater than 0. So when x greater than 0, When x is greater than 0, what is the value for phi of x? When x is greater than 0, what is the value for phi of x? It is 1, right? So we can write here 1. Is that clear? So now you know that 1 is free from x. Yeah, x को value नै छैन भने यो x is equal to 0 plus हामी केमा हाल्ने त? हाल्नै परेन. That means you don't have to write down limit here. So what is the limiting value of this function? Which is equal to 1. Or you can write down the value as 1. Okay? So limit x tends to 0 plus 1 means which is equal to 1. Because this 1 is a constant quantity which is free from x. So you don't have to put x is equal to 0 in this case, because as there is no x out there. So what is its value? It is 1. Okay? So this is your right hand limit. Next one, for left hand limit, how will you write down left hand limit? Limit x tends to 0 minus phi of x is equal to limit x tends to 0 minus. So what is meant by x tends to 0 minus? X is approaching towards 0 from which side? From the left hand side. And on the left of x is equal to 0, all the values of x are less than 0. So what is the value for phi of x when x less than 0? What is the value for phi of x when x less than 0? It is minus 1. So it is minus 1. So this minus 1 is also free from x. So you don't have to put x is equal to 0 out here. So the value is minus 1. Okay? Now in this case, right hand limit, we see that this right hand limit not equal to left hand limit. That means the function is discontinuous. No need of getting the value for phi of x when x exactly equal to 0. Okay? So if right hand limit is equal to not equal to left hand limit, from here you can write down that the function phi of x is discontinuous at x is equal to 0. So it is discontinuous, right? So here you can write, since limit x tends to 0 plus phi of x not equal to limit x tends to 0 minus phi of x. That is right hand limit not equal to left hand limit. Therefore, the function f of x or phi of x, it is given phi of x, you should write phi of x here. The function phi of x is discontinuous at x is equal to 0. So this is the answer. So the function is discontinuous at x is equal to 0. Is that clear? So you can copy it. Now we'll do the next question now. Now we'll do the next question, that is 6 number 2. Find the value of k for which f of x is equal to kx plus 1 when x less than or equal to pi. So here it is given x is equal to pi or x less than pi. If x less than pi or is equal to pi, then what is the value for f of x? It is kx plus 1. And when x greater than pi, what is the value for f of x? It is cos x. You should prove that, or not prove, you should find out the value of k for which this given function is continuous at x is equal to pi. You have to find out the value of k for which this given function is continuous at x is equal to pi. Okay? For continuity, you have to find out right hand limit, left hand limit, and the value of the function at the given point x is equal to pi. Okay? So first of all, let us find out the right hand limit. So this is the solution now. For right hand limit, you can write down that limit x tends to, so you are checking the continuity at x is equal to pi, right? So it is x tends to pi plus. X tends to pi plus, that is x is approaching towards pi from which side? From the right hand side. Okay? So now in this case you should write f of x which is equal to limit x tends to pi plus, that means x tends to pi plus means x is approaching towards pi from the right hand side, and on the right of x is equal to pi, all the values of x are greater than pi. So that is x greater than pi means it is cos x. So you should write here cos x. So what is the limiting value of cos x here? So you can put the limit pi. So it is cos pi. What is the value for cos pi? Cos pi is always minus 1. Is that clear? Next, for left hand limit, what can you write? Limit x tends to pi minus f of x. What is meant by x tends to pi minus? X is approaching towards pi from which side? From the left hand side. And on the left of x is equal to pi, all the values of x are less than pi. So what is the value for f of x when x less than pi? So is equal to limit x tends to pi minus. What does it mean? What is the value for f of x when x less than pi? When x is less than pi, then it is kx plus 1. So here you can write kx plus 1, but you can put x is equal to pi out here. Okay, you put x is equal to pi, k pi plus 1. So this is the limiting value of this given function f of x. Is that clear to all of you? So your left hand limit is k pi plus 1. Now let us find out the value for f of x when x exactly equal to pi. Okay, now at x is equal to pi, when x is equal to pi, what is the value for f of x? It is kx plus 1. F of x is equal to kx plus 1. So you can put x is equal to pi. You can put pi instead of x because x is equal to pi here, which is equal to k pi plus 1, which is equal to k pi plus 1. So this is the value for f of pi, which is equal to k pi plus 1. Okay. Now, since it is given that the function f of x is continuous at x is equal to pi. Now it is given that since f of x is continuous, f of x is continuous at x is equal to pi. Since f of x is continuous at x is equal to pi. Since f of x is continuous at x is equal to pi, so what can you write? We can write down that limit x tends to pi plus f of x, limit x tends to pi plus f of x, limit x tends to pi plus, is to write here f of x out here. Okay, limit x tends to pi plus limit x tends to pi plus f of x is equal to limit x tends to pi minus, that is your left hand limit, that is right hand limit is equal to left hand limit, that is f of x. This is your x tends to pi minus f of x is equal to f of pi, that is right hand limit is equal to left hand limit is equal to the value of the function at x is equal to pi. All these three must be equal, right? So next, what is the right hand limit? It is minus 1, or you can write what is the value of this right hand limit? It was minus 1 is equal to, what is your left hand limit? Left hand limit is k pi plus 1, which is equal to what is f of pi? What is f of pi? It is also k pi plus 1. So in this case you have to get the value for k. So either you can equate first is equal to second or first is equal to third. Okay, so now write down, or minus 1 is equal to k pi plus 1. Now we have to get the value for k, or plus 1 take it to the left hand side, it becomes minus 2 is equal to k pi, or what is the value for k out here? It is minus 2 by pi. So this is the answer. So what is the answer out here? So k is equal to minus 2 upon pi. So for this value of k is equal to minus 2 by pi, the given function f of x is continuous at x is equal to pi. So I think you have understood it. So you can copy it. We will do the next question now. So now we'll do the next question, that is question number 8. You have to indicate the points of discontinuity of the following functions. When is the given function discontinuous? At which point the given function is discontinuous? You have to check it. Okay. So in number 1, so in this case, point of discontinuity means at which value of x the function is undefined. At which value of x the function is undefined. You have to find out those values of x for which the given 3 functions are undefined. Okay. So number 1 will be a homework. So let's do number 2 now. So number 2 is, let us assume, let f of x is equal to this given function. 3x square minus 4x divided by x cube plus x square minus x minus 1. Okay. So when is this function f of x undefined? That is your point of decision. That is, when is this function f of x is undefined? That means at which value of x the function f of x is undefined. That will be the value of x will be the point of discontinuity. You have to find out those values of x for which this function f of x is undefined. That will give you the point of discontinuity. Okay. Now the fraction is given here. When is this fraction undefined? If the value of the denominator is 0, because something divided by 0 is meaningless. It is undefined. So this given function f of x is undefined if denominator is equal to 0. Okay. The function f of x is undefined if x cube plus x square minus x minus 1 is equal to, that is equal to 0. So in order to get f of x to be undefined, this denominator should be equal to 0. Or let us solve it to get the value for x. X square is common out here, x plus 1. From these 2, minus 1 is common, so it is x plus 1, which is equal to 0. Or what is common out here now? It is x plus 1 into what? X square minus 1, which is equal to 0. Okay. So you can write either or. Either x plus 1 is equal to 0 or x square minus 1 is equal to 0. So from here we are getting x is equal to minus 1, and from there what are we getting? X square is equal to 1, or x is equal to, this is your plus minus 1. So here we have got x is equal to minus 1, this is also minus 1. So minus 1 is one of the point of discontinuity. What is the other point of discontinuity? That is plus 1, because if you put x is equal to minus 1 and x is equal to plus 1 here, this function f of x is undefined. Okay. So x is equal to minus 1 and x is equal to plus 1 are the points of discontinuity. So from the definition of discontinuity, we know that the function f of x is discontinuous at the point x is equal to a if f of a is undefined. So now in this case, when is this function f of x undefined? When you put x is equal to minus 1 or x is equal to plus 1. If you put x is equal to minus 1 or plus 1, this denominator will be 0. And something divided by 0 is meaningless or undefined. So here the points of discontinuity. So points of discontinuity are x is equal to plus minus 1. So this is your answer. So I think you have understood it. So you can copy it. So we'll do the next question, that is question number 3. So number 1 say timerko homework ho. So we'll do question number 3 now. So I think you have copied it. So now we'll do question number 3. So let's do question number 3 now. So number 3 is, so what is the given function here? 1 upon sin x plus cos x. In this case also, you have to find out the point of discontinuity of this function. You have to find out the point of discontinuity of this function, that is 1 upon sin x plus cos x. That means you have to find out those values of x for which this given function is undefined. Okay, so number 3, let us do the solution for number 3. Let f of x is equal to 1 upon sin x plus cos x. Here also, when is the function f of x undefined? If the denominator is 0. So therefore the function f of x is undefined. The function f of x is undefined if denominator is 0. What is denominator here? It is sin x plus cos x is equal to 0. Okay, now let us solve it to get the value for x. So, or it is sin x is equal to minus cos x. Divide both the sides by cos x. What do we get? Sin x by cos x is equal to minus 1. Because cos x divided by cos x is 1. So we have divided both the sides by cos x. Okay. So what is sin x by cos x? That is tan x is equal to minus 1. So now tan of which angle is minus 1? So you should write down the least angle, isn't it? So or tan x is equal to, tan of which angle is minus 1? Tan of minus pi by 4. Because you know that tan of minus theta is minus tan theta. So what is tan of minus pi by 4? It is minus tan pi by 4, which is equal to minus 1. Okay. So now in this case you should write down the general values of x. You know general values from trigonometry. If tan x is equal to tan alpha, here alpha is a constant quantity. So if you want to get the general values of x, what is the formula for x? If tan x is equal to tan alpha, then x is equal to n pi plus alpha, where alpha is a constant quantity. Okay. So if tan x is equal to tan alpha, then you can write down the general values of x as n pi plus alpha, where n is any integer. Where n is any integer. Any integer means n may be 0, plus 1, plus 2, plus 3, plus 4, etc. Minus 1, minus 2, minus 3, minus 4, etc. Okay. So here also, here x is x only, x is equal to, you should write n pi. What is the value for alpha out here? It is minus pi by 4. So plus into minus is minus pi by 4. So comma where n is any integer. That means n is any integer means n is equal to 0, plus 1, plus 2, plus 3, etc. or minus 1, minus 2, minus 3, etc. Okay. So when x is equal to n pi minus pi by 4, then this given function f of x is undefined. So that means, so which are the points of discontinuity out here? That is x is equal to n pi minus pi by 4. So this is the answer for points of discontinuity. So now let us write down the answer here. So the points of discontinuity, points of discontinuity is x is equal to n pi minus pi by 4, where n is any integer. Where n is any integer. So this is the answer. So you can copy it. So now we'll do the next question now. So now we'll do the next question, that is each question carries 4 marks. Same exercise, exercise 2a. Page number is 256 from Sailendra book, right? So let's do question number 2. The definition of the function f of x is given below. The function f of x is defined as follows. That is, f of x is equal to half minus x when x less than 0. F of x is equal to 1 when x exactly equal to 3. F of x is equal to x minus half when x greater than 3. So calculate f of 3 minus 0. 3 minus is given. This is your another way of representing the left hand limit. F of 3 plus 0, this is another way of representing the right hand limit. And f of 3, you know that the value of the function f of x when x exactly equal to 3. Okay, so first of all you have to calculate the value of this left hand limit, right hand limit, and the value of the function when x exactly equal to 3, and then you have to state whether f of x is continuous at x is equal to 3 or not. Whether f of x is continuous at x is equal to 3 or not, you have to check it. Okay, so let us do the solution now. So now for f of 3 minus 0 means for left hand limit. Okay, for left hand limit. So let us write down this one, f of 3 minus 0. That means you can write it as limit x tends to 3 minus. That is, you have to check the continuity at x is equal to 3. Okay, so it indicates that this is the left hand limit, and another way of writing this left hand limit as f of 3 minus 0, which is equal to limit x tends to 3 minus f of x, which is equal to limit x tends to 3 minus. Actually, x tends to 3 minus means x is approaching towards 3 from the left hand side, and on the left of x equal to 3, all the values of x are less than 3. So if x is less than 3, what is the value for f of x? X less than 3, half minus x. So it is half minus x, which is equal to half minus, now what is the limiting value of x here? That is your 3 only. 3 minus, it only indicates that x is approaching towards 3 from the left hand side, and on the left of x equal to 3, all the values of x are less than 3. Okay, so it means 3. What is the limiting value of x? That is 3. So half minus, you can put x equal to 3 out here. So what is value now? 2 3s are 6. That is minus 5 by 2. That it is minus 5 upon 2. This is your left hand limit. Now write down for right hand limit. For right hand limit, what can we write? Limit, not limit. Let us write down this one, f of 3 plus 0. So f of 3 plus 0 is another way of writing the right hand limit. Okay, so it indicates that limit x tends to 3 plus f of x, which is equal to limit x tends to 3 plus. So what does it indicate? X is approaching towards 3 from the right hand side, and on the right of x is equal to 3, all the values of x are greater than 3. So when x is greater than 3, what is the value for f of x? When x is greater than 3, what is the value for f of x? X minus half. So you can write here x minus half. So actually this is the limiting value of x, which is equal to 3, not the exact value of 3, not the exact value of x. This x tends to 3 plus, or x tends to 3 means x exactly not equal to 3, it is approaching towards 3. So 3 is the limiting value of x. So we can write here 3. So which is equal to 3 minus half, which is equal to 3 2s are 6, minus 1 is 5 by 2. So we got this 3 minus half as 5 by 2. Now you should get f of 3. F of 3 means at x exactly equal to 3. So what is the value for f of x? What is the value for f of x when x exactly equal to 3? When x exactly equal to 3, f of x is equal to 1. Right? So put x equal to 3. So f of 3 is equal to 1. Right? So we have got all the values of this left hand limit, right hand limit, and f of 3. That means we have got f of 3 minus 0 as minus 5 by 2. F of 3 plus 0 as 5 by 2, and f of 3 as 1. So we got these answers. Now check whether f of x is continuous at x equal 3 or not. Since we have seen here that all these three are not equal, that means the function f of x is discontinuous at x is equal to 3. That means it is not continuous. So here we should write, since f of 3 plus 0, right, not equal to f of 3 minus 0, that is right hand limit, not equal to left hand limit, not equal to f of 1. All these three are not equal. That means the given function f of x is not continuous. Therefore, the given function f of x is not continuous at x is equal to 3. So this is your answer. So all these three are not equal, so that's why you can write down that the given function f of x is not continuous at x is equal to 3. Okay, so I think you have understood all the problems that we did today. Okay, so you revise all these problems at home, right? So in the next class we will do more problems on continuity of a given function. Okay, so this much is for today.